So you probably have no idea what this question's about because nobody's ever talked to you about standard deviation. Not yet, anyways. But standard deviation is how things vary amongst themselves, which is kind of a funny definition, but that's what it is. On your next form quiz, there will be a place for what's called the, I'm having a brain fart here, 68, 95, 99, 7 rule. And it's based on what we call a bell curve. It's really small, but in the middle we have the mean, the average. If we move one place over, we have the mean plus a standard deviation. If we move another place over, we have the mean minus a standard deviation. Within one standard deviation of the mean, we have 68% of the curve. If you got another standard deviation, well, you add a little bit more. Each of these little guys are 13.5%. All right. You got a little bit more, and each of these little guys are 2.35%. And then the tails at the end are each 0.15%. Now this is a ridiculously easy question. A mean of 12 ounces and a standard deviation of a half an ounce. Approximately what proportion of cans of fresh cola drink contain between 11 ounces and 12.5 ounces? So this is two standard deviations left, and this is one standard deviation right. So if I go two left, I've got these two numbers, 13.5 and 34. And if I go one right, I have another 34. That's what I have. I've got 68 and 13.5, which is 81.5%. Ta-da! Hey, you know how to do this. You were taught this last year in geometry. You multiply by the conjugate. That's also what we're doing here right now. So 1 over root 3 minus root 2 is multiplied by the conjugate, root 3 plus root 2. That should do it. Should. Up top, you'd simply have root 3 plus root 2. Down low, you'd do first and last. You'd have 3 minus 2, which is 1. So there's your answer, root 3 plus root 2. Ta-da! If one of the zeros of x to the fourth minus 8x cubed plus 25x squared minus 36x plus 20 is 2 plus I. Ooh, 2 plus I. Conjugate. It's 2 minus I. What is the complete set of solutions of the equations x to the fourth minus 8x cubed plus 25x squared minus 36x plus 20 equals 0? Here's one of them. So we have 2 minus I. We have 2 plus I, there's 2, and there are 4 answers, 4 solutions. Now, one of them might be repeated, and I have a hunch it is. And it's too early for me to teach synthetic division to y'all, so I'm just going to take a look at the graph. Graphs show real answers. They do not show imaginary answers. If this thing has real answers, it'll be on the graph. Ah, there it is. It's right there. The other answer is x equals 2. Notice how it touches the x-axis? It happens twice. Solution set of the inequality x plus 1 divided by x minus 2 is less than or equal to 1. And I'm going to do this by graphing. Put you in y1, I'm going to put you in y2. Things like this were actually pulled from your standards this year. You don't have to do them. It is what it is. Zoom 6. So, and what this is asking is, where is this graph below or on the line y equals 1? That seems to be happening here. It looks like so long as x is less than 2, this is true. It's happening for x values less than 2. So x is less than 2. Now, I don't think this will ever happen to the right. I'm going to look left about 20 units. I should not cross that line up top. It should just hover right over it. And it does. It's never going to cross that. So there you go. If we like interval notation, negative infinity to 2. That's probably how it would be presented. Probably. If log base 2 of a is m and log base 4 of b is m, what is the value of log base 8 of a over 2b? Ugh, that's horrible. It's absolutely horrible. All right, a couple of you know this so far, but you know that a log of AB over CD is log A plus log B minus log C minus log D. I'm going to use that rule to rewrite this. This is log base 8 of A minus log base 8 of 2 minus log base 8 of B. Funny, huh? Try and figure that out. In fact, I'm going to pause for a second while you figure that out. All right, now what's the next line on this thing? The next line also invokes a rule. Log base B of A is log of A over log of B. Or it's log of some C of A over log of some C of B. There's some more to it too. But anyways, I can rewrite this logarithm as a log base 2 of A over a log base 2 of 8. That's a big deal, actually. I can rewrite this one as log base 2 of 2 over log base 2 of 8. Although this one could have been evaluated. This says what power of 8 creates 2. It's 1/3. Minus, what do I have here? Log 4, log base 4 of B over log base 4 of 8. Now I can figure some stuff out. Log base 2 of 8 is going to be a number. Whoops, that's log base 10. Math number, where are you at? She's in here somewhere. She's in her math, actually. Just go to math. Log base 2 of 8 should be 3, and it is. And this becomes m, because log base 2 of a is right here. So m over 3 minus log base 2 of 2 should be 1, unless I'm just not thinking. It is. Log base 2 of 8 was 3 before, it'll be 3 again. Minus log base 4 of b is n. And log base 4 of 8 is going to be kind of ugly. That's saying what power of 4 is 8. It's not going to be pretty. It's 1.5. 1.5 is, by the way, 3/2. And this piece right here, this last piece, would be kind of funny, but it would become minus 2/3 of n. That should be the complete simplification of that one. All right, stop this one, start a new one. Notice I'm doing one page at a time.